work. Suppose there is a body placed on a plane surface. 2 points are denoted by point A and point B, and a force is acting on this body to move this body from point A to point B. So this is the initial position of the body. Initial position. As the body is acted upon by a force, it will move along the direction of the force, and after a certain time, the final position of the body becomes B. So we can say the displacement is equal to AB is equal to, say, D. It's a vector quantity, as AB has a fixed direction, and the force acting on the body is equal to F. Now the work is defined as work is equal to F dot T is equal to mod of F mod of D and cos theta, where theta is equal to angle between direction of force and direction of displacement. In this particular case, the direction of force and direction of displacement are same, so the angle between F and D is equal to 0. So in this case, mod of F mod of D and cos 0 degree is equal to 1. So F mod of F into mod of D. Simply work is equal to force into distance. When the direction of force and direction of displacement are different, then this formula takes another form. Then W is equal to F D cos theta. Suppose this is direction of force and this is direction of displacement, and the angle between F and D is equal to theta. Under this condition, W is equal to FD cos theta. Work is a scalar quantity, and unit of work in CGS system is dyne centimeter or arc. Unit of work in the CGS unit of work in CGS unit is arc. 1 arc is equal to 1 dyne into 1 centimeter. In FPS, the unit of work is foot pounder. foot pounder. In a SI unit, it is joule, and 1 joule is equal to 1 Newton into 1 meter. Suppose a body is acted upon by a force F is equal to 1 Newton, and under action of this force the body moves from A to B, and this distance is equal to 1 meter. Then we can say 1 joule work is done. 1 joule work is done in this particular case. Now, depending upon theta, the work may be positive, negative, and 0. Suppose cos theta is equal to 1 when theta is equal to 0 degree. The work is equal to F into D, Fd cos theta is equal to 1, work is equal to F into D, force into displacement simply, and this is positive. When theta is equal to 90 degree, cos theta cos 90 degree is equal to 0. So W is equal to F into D into cos 90 is equal to F into D into 0, that is equal to 0. That means work done is equal to 0. And under this condition, this type of force is known as no work force. This is the example of force and displacement D. The angle between the two directions is 90 degree, and in such a case the force is no work force and work done is equal to 0. Now when theta is equal to 180 degree, or it may be theta greater than 90 degree, theta less than 180 degree. In this region, the value of cos theta is equal to negative value. Suppose cos 180 degree is equal to minus 1. Then work done W is equal to F into D into cos 180 degree is equal to F into D into minus 1 is equal to minus FD, and this is negative work. So depending upon the situation, that means depending upon the direction of force and displacement, the work may be positive, work may be 0, work may be negative. These are 3 types of work. Now, we define power. So what is power? Power means work done by time. Work done by time is power. So we can simply write down the formula for power. Power is equal to W by T is equal to force dot D by T is equal to force dot D by T. Again, D by T, displacement by time, is velocity is equal to force dot velocity. So power is equal to P is equal to force dot velocity. This is an important formula. You have to do problems by using this formula. We can define power in such a way: when an agent is doing work continuously, when an agent is doing work continuously, the rate at which it does work per unit time, the rate at which the agent does work per unit time is known as power. So we have the definition of power like this. Now, the CGS unit of power, CGS unit, arg per second, as power is equal to work by time, so unit of work by unit of time. SI unit, joule per second, this is known as watt. There is another unit that will be useful for problem solving purposes, that is known as HP. HP is another unit of power. Now we will define what is HP. Suppose there is a body of mass m is equal to 550 pound. The mass of the body is equal to 550 pound. Okay. And the external agent lifts the body from ground through a distance 1 foot. So very simple example: a body having mass 550 pound, and we have employed an external agent to lift this body or this mass through 1 foot. Then, according to our definition of work, the work done by the agent is equal to 550 foot-pound. And if this work is performed within 1 second, then the power of that power is equal to W by time is equal to 550 foot-pound, not foot-pounder, foot-pound per second. So power is equal to 550 foot-pound per second. And this power of that external agent is known as 1 HP. 1 HP. So we may define HP in such a way: 1 HP is equal to 550 foot-pound LB, actually LBS, per second. So this is a particular unit for problem solving purposes. This body mass not necessarily be 550 pound. It may be 55 pound. It may be 55 pound, and it has been lifted through 10 foot. So if we multiply foot and pound, that gives 550. 55 pounds into 10 foot is equal to 550 foot-pounders. Okay. The conversion factor between foot-pound per second, or HP, and watt, you must remember this: 1 HP is equal to 746 watts, nearly. And 1 watt is equal to 10 to the power 7 hours per second. So these all the formulae are useful for problem solving purposes.